Today we're going to study about non-recursive predictive parsing. So non-recursive represents recursive means implicit use of stack. Non-recursive means explicit use of stack. Now let us study how the predictive parsing traces the input given. Now let us consider this diagram. So non-recursive predictive parsing. How non-recursive predictive parsing algorithm works? See, predictive parsing algorithm, that is the center part, right? It uses three data structure. One is stack and the parsing table M and the given input. Okay. So it produces output. So initially the stack, so in the stack, it uses a special symbol called dollar that is placed onto the stack. Similarly, in the input buffer, the dollar is used to represent the end of the input. And the parsing table for whichever the grammar will construct the parsing table, right? So using this parsing table, the predictive parsing algorithm makes the move. Okay. So let us study how the algorithm works. We studied what is input and what is output. Now let us study the working principle of this parsing algorithm. See, the predictive parsing algorithm, it will set the input pointer to the start symbol of W. What is W? Input. Where will place W? W will be placed in the input buffer, and we have a special pointer called IP that is pointing to the starting symbol of W. Set X to the top stack symbol. What is initial symbol in the stack? Dollar. After that, what we have to do? We have to place the starting symbol onto the stack. Next, we have to do this while dollar not equal to, sorry, X not equal to dollar. Okay, this is what the condition. So we have three conditions here. If X is equal to A, if X is equal to A means pop the stack and advance input pointer. Else if X is a terminal, then what we have to do? We have to output it is a error case. Else if, so we have a predictive parsing table, right? You have to go to a non-terminal called X and the input. What is the input scanned? It is A. So look at the table entry. X on A. What is the production? If there is any production, you just write as it is. Otherwise, it is an error state. You declare it is an error. So if it contain that particular entry contain production, then you have to place the production rule in reverse order to the stack. Okay. So this is what the algorithm step. So what we have to do, we have to place the production in the place of X. In the place of X means we have to pop X and you place Y1, Y2, YK in reverse order to the stack. So this is what the algorithm. Now let us study how this algorithm works. Look at this example. So this algorithm for this particular grammar, we constructed first, follow as well as the table. Okay. For the next slide, I'm going to refer this particular table. Okay. So what is the row entry here? E, E dash, T, T dash, F. And look at the input symbol id plus star open bracket close bracket dollar. Okay, so this particular entries are very important. Okay, so e on id, what is the entry? E on id is e derives te dash. E dash on plus, what is the entry? E dash derives plus te dash. We're going to use this production rule while tracing the input. Now let us consider the input is id plus id star id dollar. So we have stack input buffer. Okay. Now what is the content of stack? Initially dollar. Why E? Because E is the start symbol. Hence we'll place E onto the stack. What is the input? ID plus ID star ID dollar. Where the input pointer, I mean IP. Okay, IP is the input pointer pointing to the starting symbol. That is ID. IP is placed over ID. Now what we have to do? What is E actually? Stack top. Okay, so you just go to the table, okay, previous slide, go to the table, just verify a row E with input ID, E on ID is TE dash, right? So this is what the action, okay, you just output E on ID is TE dash. Next, what is the stack top? T. T on ID, FT dash. Output T on FT dash. What is stack top now? F. What is F on ID? F derives ID. Right. Now look at the stack top ID. Where is the input pointer pointing in the input buffer? It also pointing to ID. Hence matching occurs, right? ID is equal to ID. Now what we have to do, if matching occurs, you just pop ID from the stack. As well as in the input buffer, you advance the input pointer so that it is pointing to plus. Clear? Now what is stack top? T dash. T dash on plus. I think it is epsilon. Right. What is stack top now? E dash. E dash on plus. Verify the table. E dash on plus. It is plus TE dash. Now matching occurs. Now what we have to do? Pop stack top as well as input buffer is input pointer. IP is pointing to now ID. Advanced input pointer. Okay, now it is pointing to ID. Okay, pop plus input pointer is advanced. Okay. Now what is stack top? T. T on ID. FT dash. Right. Now what is stack top? F. F on ID. ID. Now what happens? Matching occurs. Stack top will be popped. Input pointer is pointing to star now. Now what is stack top? T dash? T dash on star. It is FT star FT dash. Now what happens? Matching. Pop stack. IP will be advanced so that it is pointing to ID now. Right. What is F on ID? F on ID. Now matching occurs. Pop stack advance input pointer so that it is pointing to dollar. Okay, don't stop because input is empty now, but still stack contains some symbol. Let us trace that. T dash on dollar, that's why we placed dollar in the predictive parsing table, right? Okay, now you just verify what is T dash on dollar. Okay, it is epsilon entry, right? Now what is E dash on dollar? It also epsilon. Okay, right. Sorry, the last step is, it is not T dash, it is E dash. E dash, okay, in the action part, the last one is E dash derives epsilon. So now the processing is complete. So this is how the predictive parsing algorithm works. Hope you understood.